Alright, so now that we are grizzled veterans of the ambiguous case of the sine law, they're giving us a whole bunch to work through and quickly determine how many solutions there are. So, angle C and ABC where... Okay, we'll start with the sides that they've actually given us. Side C is 10. Angle B is 56. That's angle B. And side B, over here, it's going to be in some direction like this, is 12. So I'm just going to put it in some general place just because it's easier to set up the sine law when you can see what you're doing. And they're asking us for angle big C. So the sine law says sine C over 10, the opposite side, equals sine 56 over 12. You solve that for sine C, and you get 10 sine 56 divided by 12. That gives you sine C is 0.691. That should be close enough. And then you go second sine, and you get a reference angle of 44 degrees. The reference angle for C is 44 degrees. That means either C is 44 or C is 180 minus 44, which would be 136 degrees. What do you think? Are those both valid? Or is only one of them valid? Or are they both junk? If C is 44, then we have our triangle would be shaped more like this. We'd have 56 plus 44, that's 110 degrees. That would leave us with 70 degrees for this remaining corner, which would be all right. That one's legal. What if C is 136? Then our triangle contains 136 degrees here, plus 56 degrees here, which makes 192, and boom, we're over budget on degrees, and we haven't even counted this angle yet. So this 136 cannot possibly work. The only possibility is that C is 144, so this is not an ambiguous case. With the measurements they've given us, there's only one triangle that's possible. Ambiguous would mean that either one of those could work. Now, here it comes again. PQR, they're describing things a little differently here, which is irritating, but oh well, we'll deal with it. RQ is 3 centimeters, so this is a line with R and Q at the ends, and its length is 3. QPR, what have I done? You know what? I should have started with this side because this angle is connected to PR, and I know how long PR is, so forgive me, I'm going to amend my drawing. There we go. We want the side and the angle to be connected, and that will be the case if I start with PR. So version 2, here's P, here's R. Their length is 4.2. The angle QPR is 41, so I don't know where Q is, but it's somewhere up here. That angle is 41. And RQ, this is the unknown side, I'll just put it in some random place, is 3. So we can say that the sine law, they want us to find angle PQR, which is this angle, is going to be sine Q over 4.2 equals sine 41 over, and its opposite side is 3. Solve that, and you get sine Q equals 4.2 times the sine of 41 divided by 3. Sine Q is 0.918, which which means our reference angle is, according to this, 67 degrees. That would be Q ref, the reference angle for angle Q. Which means, almost done, either Q is 67 degrees or Q is 180 minus 67. Right? We're talking about either there's a 67 degree angle in quadrant 1 or there's a 67 degree angle in quadrant 2, which would be 113 degrees big. Would this work? 67 plus 41 makes 108 degrees. Yeah, that's fine. That leaves 72 degrees for up here, so that's no problem. Or for down here, sorry. If Q is 113, then we have 113 plus 41 makes 154 degrees, which would leave us with 26 degrees for down here. Also valid. So in this case, I believe both angles are okay.